Let's look at right circular cones. We know what a cone looks like, and we have already looked at this in previous studies. So now let's say V is a fixed point called the vertex. Vn is a fixed line called the axis. L is a variable line through V, making a constant angle, that is alpha. Now, so right circular cone would be the surface generated by the line L as it moves around the axis Vn, making a constant angle with respect to Vn. So here alpha is called the semi-vertical angle of the cone. L is called the generator of the cone. Now there is something called as guiding circle. That is nothing but the section of the cone by a plane perpendicular to the axis of the cone. This is a circle. Okay, now let's actually try to look at it analytically. So let's copy this. Let's say the position vector of V is A. So this is A. Axis is along, let's say, vector beta. So beta. And imagine P is a point, an arbitrary point on the cone with position vector as R. So we have to look at angle between two vectors, and we know what that is. Cos alpha is equal to Vp beta divided by the magnitude of beta and magnitude of Vp. Now remember, here beta is not equal to 0 and the magnitude of beta and magnitude of Vp is not equal to 0. This is nothing but our cosine rule. Now we know Vp would be equal to R minus A. So cos alpha would be R minus A times beta divided by magnitude of beta times magnitude of R minus A. So our equation of the cone would be magnitude of beta times magnitude of R minus A cos alpha is equal to R minus A times beta. So this is the equation of the cone. Now if the same thing we have to look at, now remember this is vector form. Now if we have to look at the Cartesian form, just identify R, A and beta in coordinate form. So let's say A is equal to x1, y1, z1. Beta is equal to, let's say direction cosines are L, M and N. R is equal to, let's say x, y and z. R minus A would be x minus x1, y minus y1, z minus z1. Now let's just substitute it back to the vector form. Magnitude of beta, that is L square plus M square plus N square times magnitude of R minus A. So x minus x1 square plus y minus y1 square plus z minus z1 square. Cos alpha is equal to r minus a times beta. R minus a would be x minus x1 I plus y minus y1 j plus z minus z1 k times beta. Beta would be what? Vector beta. Vector beta would be li plus mj plus nk. If we simplify this, the dot product, we get x minus x1 L plus y minus y1 m plus z minus z1. What we want to do is remove the square roots. So to remove the square roots, we square both the sides. So this becomes L square plus m square plus n square, x minus x1 square plus y minus y1 square plus z minus z1 square cos square alpha. Since we are squaring both the sides, so x minus x1 square plus y minus, no, there is no square here. We will put the square on the overall this one, y minus y1. This is L, this is m plus z minus z1 n square. Yes. So this is the equation of the cone in Cartesian form. Now, what if V is at the origin and axis is the z-axis? Now, because of the first, what will happen? V would be 0, 0, 0. And because of this, axis is the z-axis, L would be equal to 0, M would be equal to 0, and N would be equal to 1. So let's apply these values to this equation. So therefore, L square, M square, N square. So 0 square plus 0 square plus 1 square. X minus 0 square plus y minus 0 square plus z minus 0 square. Cos square alpha is equal to, what is the equation again? X minus 0 times 0 plus y minus 0 times 0 plus z minus 0 times 1. So which implies x square plus y square plus z square cos square alpha is equal to, this becomes 0, this becomes 0, and we are left with z. By the way, this is going to be square. Yes. Let's verify with the equation. Yes. So this will be z square. Now x square plus y square plus z square is equal to z square by cos square alpha. Okay. X square plus y square plus z square is equal to z square. 1 by cos square alpha is sec square alpha. Now sec square alpha can be written as 1 plus tan square alpha, right? Which means if we distribute it, we get z square plus z square tan square alpha. So if we write this side also, z square get cancelled, and we are left with x square plus y square is equal to z square tan square alpha. This is the equation of the cone with vertex at origin and axis on the z-axis. Another way in which this equation can be derived is, imagine this is the coordinate system, okay, and let's say this is the cone, vertex is at origin. Let's say we have an arbitrary point P. There is a perpendicular to the z-axis. So P is an arbitrary point. Any point on the cone. PM is perpendicular to axis, which is on the, remember, z-axis. So which means M would be 0, 0, some value of z, or the point on the z-axis the same as the P. Okay, so triangle OMP, let's focus on that. Tan alpha, remember this is alpha. Tan alpha will be opposite side by adjacent side. So MP by OM. Now let's square the square both the sides. So what do we get? We get tan square alpha MP square by OM square. MP square would be x minus 0 square plus y minus 0 square plus z minus z square divided by OM square would be what? OM square would be z square. So this would be x square plus y square plus 0 square by z square. So z square tan square alpha is equal to x square plus y square. So this is the equation of the cone with vertex at the origin and the axis on the z-axis. So that's it for today. Bye for now.